Hello, this is Barrett from the C4 Cyber Club here at Cypress College. In this video today, we're going to cover the CySA Plus Lab series based on web application scanning. So we're going to be looking at tools like Nikto for the command line to do some web app scanning, and also Owasp Zap, which can also act as a intercept or proxy, where we're going to actually take a look at intercepting HTTP requests, for example, and how we could potentially manipulate those. So this is all getting into layer 7, the realm of HTTP floods, SQL injections, and of course, like we just mentioned, web proxies. In fact, I was going to go over the objective or introduction here. So web application penetration testing is a complete field within the penetration testing discipline. All of the action takes place at the application level, like I was saying, layer 7. Many of the same types of tactics that are used for a general penetration test also apply to web application testing. So yeah, let's go ahead and dive on into it. If you're in the CIS 196 class, you probably have been used to using the ethical hacking labs, but now, as a reminder, we are in the CySA Plus Lab series now. So you want to make sure to load into that. And with that, you'll notice that the topology is slightly different, but still the same concept. Today we're going to be working on the Ubuntu and Kali machine. And the first thing that we want to do is log into the Ubuntu. So I've already logged into mine. You'll notice that the lab lays out the login information. So password is password123. And the first thing that we need to do, and this is a bit outside of the scope of this particular course or this lab, but the website that we're going to be working with is called Budget, and it runs within a Docker container. So first thing we need to do is actually run that Docker container. And essentially what this is, it's a form of virtualization where all of the particular dependencies related to this web app are all within that Docker container. So we just need to launch this so that we will actually be able to connect to the website. So we'll type in this command here, Sudo Docker Run. And sudo, of course, is basically saying that we will allow this command to run with root level privileges. Okay, so we're signifying a port of 8080. Whoops, I missed a 0 there. Definitely want to make sure that you have no mistakes on the syntax of this command. Okay, and then when it asks you for the password for sysadmin, keep in mind this is the password for this Ubuntu machine. So that again is password123. And then we're given essentially like a process ID. So at this point, we know that the Docker container is running. We could even say sudo docker ps for processes, and we could see that the Budget application is running, and we have that going on port 8080. Okay, so now we have that running on the Ubuntu machine. Now we come to our Kali machine. Remember the password, login and password for this is the same. Login is root, password is TOOR, or root backwards. And so now we'll want to open up Firefox, and we're just going to visit the URL that is the Ubuntu IP address at port 8080 and then /budget, which is basically the location of that Docker container web app that we just launched. So let's go ahead and type that in, port 8080 /budget. Okay, and so here you see we have a very basic web app, and it's looking like this is an actual storefront. So you can actually navigate through here and potentially do a bunch of different web app hacking practices throughout this purposely vulnerable website. But we'll go ahead and keep following along with the lab. So we're going to start off by using Nikto. So Nikto is a command line web app scanner. Okay, so we'll want to open up the terminal. And now we have this command to run here. So let me go ahead and type it out, and then we can kind of break this down. Actually, you know what, in fact, what we could do is say Nikto-H for help. So remember, this is always a good idea as you are using a tool for the first time. Just take a look at the help, and you could even, remember, you could do man Nikto to pull up a manual file for this. So, Nikto, this is a scan web server for known vulnerabilities, gives you a brief description, server and software misconfigurations, default files and programs, insecure files, outdated servers. This is all the types of things that you can look for using Nikto. And if you press spacebar, you can get to even deeper level overview of all of the different options available. So I'm going to press Q to quit. And you can see here we have multiple options. So we have the dash host. And you can see here, here we go, dash host, target host. That makes sense. We set the target of the IP of the Ubuntu machine. Dash port, we're signifying the port that it's on. So that is running on 8080. Now the dash root, you might want to think that this relates to admin, root level. But this is actually saying what is the root level off of this host. So what is the folder that we're targeting? So that is, of course, the budget. So this is what refers to the dash root option in Nikto. So we're telling it that it begins at budget and it's going to scan from there. Now we are going to output this into a report. So we're signifying the format of this report is HTML, and the actual file name, the actual output, is called niktoreport.html. Okay, so as you see down here, we're going to have a nice, nice reporting and better visual reporting of this rather than just looking at it in the command line. Okay, so now that we've kind of gone over what the command means, let's go ahead and run that. Okay, so when I press enter, you can see it start working, and it doesn't take too long to scan. You can see it's pulling things from this OSVDB or open source vulnerability database, something that I'd recommend you maybe check out sometime. And one host fully tested. So, and it took about 12 seconds. So pretty quick. Now we could look at this output here, but remember, if I run ls, if I get a listing here, we created an output file called niktoreport.html. So we could actually load that up in Firefox. And I'm just going to type NIK and press the tab key. A friendly reminder, you can auto-complete commands in Linux. And you'll notice when I press enter, it actually loads that file right into a new tab in Firefox. So this is a lot more manageable. You can see things a lot more clearly here rather than in the command line. And you have various potential vulnerabilities, host summary, scan summary, etc. So I would definitely encourage you to do additional, research on some of these, like anti-clickjacking, X-frame options header is not present. Very, very easy to do a quick Google search, learn what is clickjacking, and very briefly, that is if a scenario where an attacker could potentially trick a user into clicking into something malicious and masking its true intent. So that is definitely something pretty dangerous, and it also often related to iframe injections, where you can actually inject a malicious website into a normal website. So this is something that you definitely want to fix for sure, because that's a very nasty vulnerability. And then, down here, the x-XSS protection header is not defined. And this actually tells you straight away, this header can hint to the user agent to protect against some forms of XSS or cross-site scripting. So this could potentially allow a user to run scripts, to run malicious JavaScript on the website. So another really nasty form of vulnerability. So yeah, getting used to reading these vulnerability scan reports, doing the research on it, getting a better idea of the vulnerability and ways to remediate it, and the solutions that go into that, is a very great skill to develop in your pursuit of not only the CySA Plus exam, but also just working in the industry. So moving on, we looked at the scan report. So now we're going to take a look at the Owasp Zap or Z attack proxy. So we can come back to our terminal and just launch this by typing in Zap ZA proxy. And you'll see that is going to load up. And there's essentially two different ways we're going to use this tool. One, we're just going to do a scan. And this is going to scan for all of the various web application vulnerabilities and show us alert levels. So nice thing about this, it is a graphical user interface. It has a GUI. I would recommend bringing this menu up. If I can, there we go. So bring that up because you're going to start to see results down here, especially in the alerts. So it'll be nice to have that screen a little bit bigger. But essentially, first things first, we want to add the IP address of the Ubuntu machine, and more specifically, the actual URL of the budget site. Okay, and press attack. And you could see it straight away going at it. And essentially what it's doing here, it's spidering through the website. And it's basically creating a sitemap of all of the potential areas. It's testing it for all the various vulnerabilities. And the main area here that we wanted to eventually look at is the alerts. And the lab says that this takes approximately 7 minutes, but I actually think it happens much quicker. And in fact, oh no, yeah, it's still scanning here. So I will actually let this complete and come back in just a moment once we're all done. Yeah, we're at 8% right now. So this will likely take a good 5 minutes or so. Okay, so it's looking like the scan is complete. Yep, we're at 100%. So if you take a look at this, you can see a whole bunch of different HTTP requests here. We have GET and we have POST. So GET is, when you are requesting information from a web server, for example, in this case, and POST is when you are actually sending information to that web server. So oftentimes in form of like a form or guest book submission, things like that. And that's something we're going to come into a little bit more detail in the upcoming part of the lab. But the main part to look at in this section is the alerts tab. So, and you'll notice that it has some similar results that we saw in Nikto as well. So it also caught the X frame options header not set that would help protect against clickjacking attacks, for example. And then we see also color coding of the risk, and you can see it here. So these are very high risk in terms of cross-site scripting and SQL injection. So these are two very common and very high risk vulnerabilities. So you can see where this tool goes into detail, gives you description about the attack, gives you potential solutions, and then of course also additional references. So here's a link to MITRE website, for example, and a webappsec.org website. So there's a wealth of information here, especially if you are conducting a scan on your own network or your own web app, I should say, and you're wanting to strengthen it and make sure you have the proper patches. You could give this information to your developers to make sure, for example, for SQL injection, that they are implementing strong input validation, for example. So we will be coming back to Owasp in just a little bit, but let's move on to the next section of the lab. And I believe we get into, we're going to get into using WebGoat and tampered data to do some web proxy and interception. So I'm going to close Owasp Zap for now. And then I'm going to come back into the terminal. And so we need to actually terminate the current Docker container that we have running, because we're going to start up a different one for the WebGoat application. So we can type in sudo docker ps. Oh, I'm sorry, I am on the wrong computer. We need to be on the Ubuntu machine. This is where the Docker container is running. So I could say sudo docker ps, enter in the password again, password 123. And so you notice this command where we're going to say sudo docker stop followed by the container ID. So this is important because it's different on everybody's own system as you run this lab. So you will have to choose this status number to add into your command. So sudo docker stop followed by whatever number you have here, or whatever value. Oop, looks like I had a mistype. There we go. So that ended. We could verify, say sudo docker ps. Now no containers are running. And now if I scroll down, this is where you see the command, very similar to what we ran before, but now we're going to run WebGoat. Still on port 8080. There we go, sudo docker ps just to verify. Okay, and we now have WebGoat up and running. So now, same as before, we can move over to the Kali machine. And I will close out of this. Enter the Ubuntu IP / port 8080 / WebGoat. And I believe this is, not I believe, I know for sure, this is case sensitive. So capital W, capital G, and followed by login. Unable to connect. I believe this will take a moment to load. So I'm going to give it a second for the server to really get going, and I'll hit refresh. Okay, there we go. So I just waited a moment, about a minute or so, hit refresh, and now you could see the WebGoat login. So if that happens to you, if it tells you that it's unavailable, just wait a minute or two and then give it a refresh. And of course, double check and make sure that your URL is correct and case sensitive. All right, so now we will reopen Zap. So open that in the command line. That loads up again. And in this case, we're going to actually launch a browser that is built in to Zap. So if you scroll down in this main window here, down at the bottom underneath, so before we ran the attack, this time we're going to kind of use it manually to intercept traffic as we use the site and browse and make requests. So we'll say launch browser. Okay, so now we will once again log back into WebGoat from this URL. So this is where we will be making requests. Because this is a web proxy, it's going to intercept all of these various requests that we do with the web server. Okay, there we go. So now we want to register a new user in this case. So let's go ahead and click there. We're going to set up a new user called student. Set a easy password just as password. Not recommended in the real world, but just for ease of use, we'll set it up like that. Okay, so terms of use, this is important to think about. So remember, WebGoat, much like Bodget, it's a purposefully vulnerable web app. So if you ever decide to maybe run this at home, for example, this is important to know that if you put this on your own system and make it available to the public, it makes your system very vulnerable. So don't do that for sure. It is possible to download this and place in a VM environment like VMware or VirtualBox. So that, would be encouraged. That's a great way to learn. Or of course you can continue learning through these NETLABs. So, while running this program, your machine will be extremely vulnerable to attack. You should disconnect from the internet while using this program, et cetera, et cetera. So, but keep in mind, not while you use NETLABs, because they are purposefully sandboxed and no connection to the outside. So you're good. So in this case, we'll agree with the terms and conditions and sign up. All right. I encourage you to go over and read this. What is WebGoat? Like we've been talking about, a deliberately insecure application that allows interested developers just like you to test vulnerabilities commonly found in Java-based applications that use common and popular open source components. So this is all about finding cross-site scripting, SQL injection flaws, things like that. But this lab, we're going over the HTTP basics. But you could always log back into this lab and do any of these essentially tutorials, because it's all very guided. So it serves as a good learning tool. So first thing we'll do is go to General HTTP Basics. So how HTTP works, all HTTP requests or transactions, follow the same general format. Each client request and server response has three parts: the request, the response line, a header section, and then the entity body. So the client contacts the server, sends a document request. So remember, we were talking about that earlier. That would be a GET request. You're requesting something from the server. And this can have URL parameters, and those parameters will be available in the web access log. So this here would be an example of a parameter. So next, the client sends optional header information to inform the server of its configuration and the document formats it will accept. So user agent Mozilla here, this is basically saying usually what type of web browser is being used and then what type of documents it is able to accept back. And then in a post request, the user supplied data will follow the optional headers and is not part of the contained within the post URL. So let's move on to the second page here. And so we could see an illustration of how the server can receive information from you and then actually return back something different. And in this case, the server is going to accept the request. It's going to reverse the input and then display that back to the user. I'm going to put my name, and you see that the server got my request and then it acted on it and displayed this. So the way that this relates to attacks is that I could have maybe potentially input a malicious script in terms of like cross-site scripting. And if you can get the server to receive that and then reflect it back to a browser, then it could potentially be used to target other users, especially if you're dealing with things like a public guest book, which I know aren't, or like a comment section. So if a comment section on a website or a blog allows for this kind of user input that will just automatically get reflected back to the users, and if there isn't proper input validation, then that could be a big problem. Now, let's see what this looks like on the web proxy. Because remember, we're using the Zap browser. And then if we look within Zap itself, under history, we have, this is basically all of the browsing that we've been doing. So it logs everything. It logs all the GET requests, and it also logs the posts. So when we clicked on, let me pull that back up again. When we clicked on Go, this sent a post request to the web server. And we could see that post request right here. And that was at this site. So we were in the HTTP basics and attack 1. So if I double click on this, you could see the original request. So here was the input. And then you can also review the response. So this was the feedback that was sent back. The server has reversed your name, and then there's that. And so within here, a lot of this is a bit outside of the scope of this introductory lab. But as you start to learn more about HTTP and the way that the web works, this is all of that. It's showing the post, it's showing header information. It's also showing session information in the form of a cookie. So one thing to think about is HTTP is stateless, where it doesn't necessarily keep track of connections. And that's why we have cookies in order to try and keep track of the browsers and actual sessions as users are logged in, right? Because otherwise, a website would not be able to know who's who, for example. Okay, so let's keep moving on. We checked out both the request and the response. And now next, we're going to take a look at hidden variables. So you can see here in the lab, it points out web pages often pass hidden variables to the web server that users never come in contact with. And this could be used for multiple reasons. And sometimes the user shouldn't necessarily know this information, but we're going to see there are ways to intercept this information. So for the next exercise, this variable is referred to as a magic number. So going back into WebGoat, we'll select the third page here. And it asks, what type of HTTP command did WebGoat use for this lesson, a post or a GET? But first thing we need to do is try to determine what the magic number is, because you can see it's asking us, okay, was it a post or a GET? And what is the magic number? So we can intercept this. We could press go. So it says you are close, try again. The HTTP command is incorrect. Okay, that makes sense. We didn't enter anything in. However, because we are running a proxy, we can look at that post. And so now we see here, okay, the magic number is 85, and that's sent as a post, right? So we can come back to the website, and we will enter in post. 85 was the magic number, and then it says, congratulations, you have successfully completed the assignment. So this is one example of how you can potentially intercept useful information that is often hidden from normal usage, but it is happening in the background, and running something like an interception proxy can help you find that. And we could even take this a step further and show how you can manipulate from within the proxy itself. So let's see, if we reset this lesson, go back to 3. Oh, I think I have to go to 2 first. Okay, there we go. Now let me press go again. We got another post. Okay, so the magic number stayed the same. But now instead of entering it in here, we should be able to enter it in here. So let's see, answer equals post. Oh wait, no, sorry, I have to right click. Okay, so let's open this with the request editor. That's what I was looking for. Okay, so within here, I can edit this information. So the answer, the first answer is post. The magic answer is 85. So I'm changing this within the proxy, and then I could actually send this. And you could see here, congratulations, you have successfully completed the assignment. It doesn't necessarily show up here, but we're able to tell on the server side what kind of response we would get back by what type of request we send. And this is generally how you may have heard the term bug bounty. This is how a lot of people who pursue bug bounties or generally do web application pen testing will work. They'll use something like Zap, or Burp Suite is another really popular interception proxy where they can test out requests and see what type of responses they get. There's also ways to, using Burp Suite, for example, just to kind of explain how far you can kind of go with this and manipulating requests and responses. You could potentially do a brute force attack. You could figure out the parameters of, let's say, what it asks for, a password. You could maybe set a section where you would then load a word list filled with possible passwords, and then run that as a brute force attack, and it will just keep trying all the different responses. And then depending on the response, and this is where actually HTTP response codes come into play too. It's something you'll learn more and more about. If you're in the 200s realm, you're good to go. 300s generally mean you need to redirect to this. I know where it is. It's not here, but I'll redirect you. 400 realm status is kind of like you've made a mistake. You've probably familiar with error 404, code 404. Website is not here. What you're looking for is not here. And then around the 500 realm, this is more of a oops, we messed something up on the server side and something's terribly wrong. So, like I said, I'm getting a bit out of scope for this particular lab, but just thought I'd kind of mention the possibilities when it comes to manipulating request and response fields like that. So with that, yep, this concludes the lab. Hopefully I didn't ramble too much about other things, but this WebGoat is an extremely useful training tool. So like I said, feel free, you could log into this lab as much as you want. Practice with any of these areas. WebGoat is a fantastic learning tool. even outside of just these HTTP basics in this lab. So great. Hope you enjoyed. Thanks for watching, and I will catch you in the next one.